AP Cactus AB, Unit 8, Day 9, office hours. These are the answers, which you should have checked already, hopefully, but here they are again, real quick. Pause the video if you need to check these. I'm only going to up here very briefly. Here's the other answers, just the answers. It's the back. Answers. Pause the video if you need to. Okay. So let's try these problems out now. There is some gravity on them, but there's also a bunch of non-gravity problems, so it's just good practice in general. All the rectilinear motion, one-dimensional motion that we've been talking about. Johnny's walk along the number line yields his position as this. Find his velocity at 2. Well, we should probably go ahead and find his other equation. So velocity would be 3t squared minus 12t. Acceleration would be 6t minus 12. So that's all helpful. So velocity at time 2, we just plug 2 into that equation. Show your work, label your work. If you want to get credit, even if you make a little mistake. It's going to be 12 minus 24 is negative 12. We don't have any really units on this problem. It's not velocity. It's not a gravity, so it's fine. You don't have to have units. It's acceleration at time 3, so we would just plug 3 into the acceleration equation. And we get 18 minus 12 is 6. So that's the acceleration at time 3. Label your answer. Okay, maximum velocity. Okay. Well, we need to do EVT on that, right? We have endpoints here. We need critical points, turning points. Critical points for velocity. So we got to take the derivative of velocity, which is acceleration, and set it equal to 0 and define critical points for velocity. And so if we do that, we get t equals 2. That's your critical point. And then we're going to make a table, like we always do, plug time in, and plug it into velocity. I'm not looking for max position, max velocity. I could ask you for max acceleration, max position, max velocity, min, whatever. So we're going to put the endpoints in and the critical points in. Plug them into velocity, you get 0. Here you're going to get 12 minus 24 is negative 12. You're going to plug 5 in, you're going to get 75 minus 60 is 15. So there's your max velocity. This is your min. And so we'll, say some answer. The maximum velocity is 15 at time t equals 5. If I asked you to justify, you'd say by extreme value theorem, checking endpoints and critical points. But that's the work you should show. Okay, the time at which he is furthest to the left. Well, that's the same as min position. Smallest position. It could be negative. So this is another EVT problem. It says time, so I guess maybe we're going ahead and using the same endpoints as the previous problem. I guess that's a little bit of an assumption, but let's go for that. We got to find when is s prime, which is velocity, equal to 0 undefined, and that's 3t squared minus 12t equals 0 undefined. Define critical points of position, which we also call turning points. Factor it, 3t, t minus 4 equals 0 undefined. T equals 0 and 4. So these are your critical points, turning points for position. We're going to make a table. Plug it in position, which was t cubed minus 6t squared plus 1. So you plug in 0, 4, and 5. Plug 0 in, you get 1. Plug 4 in, you get 64 minus 96 plus 1 is negative 32, negative 31. Plug 5 in, you get 125 minus 150 plus 1 is negative 24. So this is your min. or leftmost. This is your max or rightmost. So he is furthest to the left when s equals negative 31 at time t equals 4. So I always state what the maximum is and when it happens or where it happens. That's not even justification. That's just good. When it is speeding up, so we're looking for acceleration and velocity to have the same sign. So the easiest way to do this is with line checks and do them above and below each other. Now we have, I think, everything we need. So velocity equal to 0. We just found that was 0 and 4. Test a value t equals 5. Positive, negative, positive. Acceleration equals 0. We found up here was 2. So just line them up relatively correct. Test a point. Tell me what you test. I'm going to test 3 in the acceleration equation. That's going to be positive and negative. So speeding up is when they have the same sign. So those spots. So we're going to say 0 to 2 and then 4 to infinity. Now, should we include the endpoints or not? Well, we usually include the endpoints for velocity, which would be 0, and it's in the middle of acceleration, so we keep that. 2 is the endpoint of acceleration, so we don't. 4, we keep it because it's the endpoint of velocity, the whole increasing, decreasing thing. But now here's the deal. I'd get this problem wrong if we were still using these endpoints, because if we're using those endpoints, then we actually still have to cut it off at 5. So it just kind of depends if these are applied to part E or not. Okay, so this is where they're speeding up when they have the same sign, slowing down when they have opposite signs. So I feel like the easiest way to figure that out is with line checks above and below each other. All right, I've given you acceleration equation, initial velocity, initial position. I want you to find the final position equation. So we have to work backwards twice. So velocity is the integral of v prime, which is the integral of acceleration, which is the integral of sine 2t. And I think I'm okay with skipping the whole U-substitution thing because the extra 2, don't ignore it. It's one that you could use U-substitution on. It's a chain rule issue. It's definitely going to be cosine 2t, right? But cosine is going to give you extra 2 in front that we don't want, so we need a 1/2. And we also need negative plus c. So then we plug in times 0. And it should come out to 4. Now cosine 0 is 1, so c is going to equal 4.5 or 9/2. Usually you don't put mixed fractions. So your velocity equation is negative 1/2 cosine 2t plus 9/2. So you're halfway there. So then position is going to be the integral of the derivative of position, which is going to be the integral of velocity, which is going to be the integral of negative 1/2 cosine 2t plus 9/2 dt. You need the parentheses, you need the dt's. I want all this down here. This shows that you understand what you're doing. So we're going to get sine 2t, and that's going to give an extra 2 in front when we actually want a 1/2. So we already have a 1/2, and then we need another 1/2, and then plus 9/2 t plus c. I mean, you could do U substitution to get that extra 1/2, but that's what we're going to get. So we can plug 0 in. And it should come out to 10. So these go away. So c equals 10. So your final answer for position is negative 1/4 sine 2t plus 9/2 t plus 10. That's it. Okay, next one. I'm giving you acceleration, initial, and velocity and position. So you probably kind of want to just do the same thing we just did. We have acceleration is 12t minus 12. So velocity is going to be the integral of v prime dt, which is going to be the integral of acceleration, which is going to be integral of 12t minus 12 in parentheses dt. So velocity equals 12t squared over 2 minus 12t plus c. You use initial position at velocity at time 0 is equal to 0, which means c equals 0. So velocity equation is 6t squared minus 12t. That's that. And then position is going to be the integral of the derivative of position, which is going to be the integral of velocity, which is going to be the integral of 6t squared minus 12t dt. So I'm doing all this work up front, and we're going to have to do it. Might as well just do it now. Okay, so position equals 6t cubed over 3 minus 12t squared over 2 plus c. And then we're going to use initial position to find the c value right now. And it's supposed to come out to 0, and that's all 0, so c equals 0. So your position equation is going to be 2t cubed minus 6t squared. All right, so that's probably all going to be really helpful. When is Johnny slowing down? Dang, we need new acceleration and velocity for that. We need to know when there's 0, so we can do line checks. So when is the acceleration 0? It's not too hard. Okay, so we'll use that for that line check. And then velocity, when is velocity equal to 0? You get 0 and 2. So I'm going to do a line check for acceleration. I could do it over here, I guess, and velocity right here. So we're going to do 0, 2. I'm going to do 1. I'm going to test a point. T equals 2 is going to be positive, negative. Test a point here. T equals 3. Positive, negative, positive. So when is slowing down? When the sign is opposite, which is here, but we're not going to include those for final answers in here. So we're going to say 1 to 2. And usually we include endpoints for velocity, but not acceleration. So I'm going to say that's when it's slowing down. This is also part of it, but we're not including negative time. So first one is 1, 2. Okay. Position when its acceleration is 0. So when its acceleration is 0, which we found out was at time 1. So we really just want the position at time 1. So we plug that into our position equation. And we get negative 4. So there we go. And then minimum position. Well, these are your endpoints. We're going to do EVT. We need, so min position means we need the derivative position, which is velocity, which we already figured out. 6t squared minus 12t equals 0 undefined to find critical points. We actually already did this work, but we can do it again real quick if you want or not. You can just use it. So we got t equals 0 and 2 were critical points. So we're going to make a table, plug it into position, 0, 2, 4, plug 0 in, you get 0, plug 2 in, you get 16 minus 24 is negative 8. You plug 4 in, you get 64. 128 minus 96 is 32. So this is your max, this is your min. We don't do negative time, but we can get negative position. So we're looking for minimum. So the minimum position is negative 8 at time t equals 2. That's good thorough answer. Now, if I ask you justify, you'd say by, you guys should be good at this by now, by extreme value theorem, which is the name of it. Cool. How does it work? By checking endpoints and critical points. And don't abbreviate anything if you're actually trying to justify it. Write it all out. No initials. So that's a good answer with a good justification. Okay, so let's see. Let's try the problems on the back. So this time I'm giving you position and initial, or velocity initial position. So acceleration would just be -2 sine 2t. You got to do chain rule. Position is going to be the integral of s prime, which is going to be the integral of velocity. So that's going to be the integral of cosine 2t dt. We could do chain rule or U-substitution, but I feel pretty comfortable saying, okay, well, I know it's going to have a sine 2t positive, because the derivative sign is positive cosine, but extra 2 is going to pop out that I want, so I need 1/2 in front, plus c. So all the U-substitution you do would just give you that 1/2. Now let's use the initial condition of 0. It should come out to 1. Sine of 0 is 0, so c equals 1. So your position equation is 1/2 sine 2t plus 1. So that's your position equation, acceleration equation, and velocity equation. So Johnny's acceleration at time pi over 3. So we're just going to plug pi over 3 into acceleration. So it's going to be 2 pi over 3. So the reference angle is pi over 3, and we're in quadrant 2. So for sine pi over 3, pi over 6 is 1/2. It's root 3 over 2, and it's positive in quadrant 1 and 2. So it's going to be negative root 3 is your acceleration at pi over 3. Show your work, label it, show your setups. Okay, his acceleration when velocity first reaches 0. Okay, well, we got to figure out when his velocity equals 0. So we have his velocity, and we're going to set it equal to 0. When does cosine equal 0? At pi over 2 plus pi k. So we're going to divide by 2. So t equals pi over 4 plus pi over 2k. So there's infinite answers. We just want the first one. There's first positive time. So that's t equals pi over 4. So then we want the acceleration. So we're going to plug it into pi over 4. -2 sine of 2 times pi over 4. So it's going to be pi over 2. Sine pi over 2 is 1. So we're going to get -2 times 1 is -2. That's the acceleration at pi over 4, which is the first time velocity reaches 0. Okay, Johnny's velocity when his position is 1.5. So what's the velocity when? So we've got to figure out what's the time when the position is 1.5. So we can take the position equation, 1/2 sine 2t plus 1, and set it equal to 1.5, which is 3/2. We're going to subtract 1. So we get 1/2. We're going to solve for sine 2t and get 1. So that's going to be 2t equals pi over 2 plus 2 pi k. Divide by 2. T equals pi over 4 plus pi k. So there's infinite answers, but I'm assuming maybe they all just end up giving us the same thing. So we'll just go with pi over 4. So what's the velocity when it's pi over 4? So plug in the velocity equation, cosine of 2 times pi over 4, which is pi over 2, which is 0. Now, if we were to plug other answers in pi over 5 pi over 4. Well, the reference angle would still be pi over 4. It'd be 5 pi over 2. Well, that's still going to give you 0. So no matter what time you plug in, it's always going to give you 0. Okay, so none of those are gravity problems. So here's your one gravity problem. A rocket is launched by the AGHS robotics team vertically upward from the top at the Clark Center of 128 feet at 32 feet per second. So this is your initial position. This is your initial velocity. And so we should probably just try and find all the equations first. So I'd memorize position equation due to gravity is 1/2 gt squared plus v naught t plus s naught. And g for us is negative 32 feet per second squared if we use English units. So it's going to be negative negative 16t squared plus 32t plus 128. So it's your position equation. Velocity is going to be negative 32t plus 32. And acceleration is going to be negative 32. It should always be negative 32 for gravity problems because that's the only acceleration that is affecting your motion. So those are equations. Velocity at time 1. So we're just going to plug 1 into our equation. Label your work. Show your work. Just in case you're entering the wrong thing. So we're going to get 0. And the units on here are feet per second. So we do units for gravity problems because we're assuming feet per second squared when we plug g equals negative 32 in. Maximum height. So this is EVT. So we need endpoints and critical points. So here's, the endpoints usually are going to be time 0, and then when it hits the ground. So we need to find time to impact, and that's going to be when position equals 0. So we can factor negative 16 out. Let's see. This would be 6. Is that 8? 8? Now, usually you're going to get 2 answers every time for time of impact on these gravity problems. And if it starts at ground level at the beginning, then t equals 0 makes sense. But the negative time is like pretending it keeps going. It started at this height and it's going like this, and it's pretending it keeps going and hits the ground over here in negative time territory. But this didn't really happen. So it's got to be this. So that's time to impact. Endpoints are going to be when maximum height when s prime, which is velocity, which is negative 32t plus 32 equals 0 undefined. So we got to find critical points for extreme value theorem. So we can factor that out. So t equals 1 is your critical point. This is an endpoint. Your other endpoint is time 0. So I think we're ready to make a table. Plug these times into position or height, which is negative 16 t squared plus 32t plus 128. So we're going to plug 0 in, 1 in, and 4 in. So you plug 0 in, you get 128, which makes sense. This initial height. Plug 1 in, 16, 144. Plug 4 in, you should get 0 because that's how we found 4. I mean, you can double check your work, but you should get 0. So here's your min. Here's your max. So we could say the maximum height of the rocket is 144 feet. Need units on here. At time t equals 1 second. So that's a good thorough answer. If you want justification, say by extreme value theorem, by checking endpoints and critical points. Velocity of impact. Well, we already found time of impact was 4. So we got to plug that into the velocity equation. So just show your work, show your setup. So this is going to be negative 128 plus 32, right? 4 times 30 is 120. So that's going to be negative 96 feet per second. And it should be negative. It's coming down, right? When it hits the ground, it should be negative. Okay, average velocity. Now we've talked about this before. This is like average derivative. So V average does not equal for the entire trip. So that means T equals 0 to T equals 4. So you need time of impact for this and this and this. So now it's not going to be V4 plus, V0 over 2. It's not going to be V4 minus V0 over 4 minus 0, which is closer, but this is average acceleration, okay? So average velocity is the average derivative. This is mean value theorem for derivatives, and it says just take the slope between the endpoints of the original curve. V is the slope of the position curve, so you got to use the slope of the position curve, rise over run, to get the average velocity. So this is a setup, okay? I think we already calculated S4 was 0. S0 is 128. So we get negative 128 over 4, which is negative 32 feet per second is your average velocity, feet per second. Negative, which makes sense. There's more negative velocities than positive velocities. So these ones kind of cancel these ones out because there's all these positive velocities and matching negative ones, and then a bunch more negative ones because we started above the ground. Height of the rocket when the velocity is negative 96 feet. So when the biggest, probably the hardest part is finding the time. So velocity, when we take the velocity equation, negative 32t plus 32, and set it equal to negative 96, and then solve. So that's the time, and I'm going to plug it into the position equation. And I think we've already calculated this a couple times, but we could do it again. 4 squared plus 32. I don't think I actually calculated this. I assumed it was 0 earlier because that's how the time 4 is actually time of impact. So it's going to be 16 times 16. And 16 times 16. What's 16 times 16? I think it's 256, right? 6 times 6 is 36, carry 3, 9, 0, 6, 1, 6, 15, 256. Plus, this is going to be 128. 128 is 256. So we get 0. Still got to put units, feet, when velocity equals negative 96 feet per second. So we're kind of answering some of the questions that we've even asked before with motion problems back in chapter 1 on some of these. So that's it.